Okay, let's look at this example. So again, if you look at the diagram, this is a cylindrical bar or rod without insulation layer. Okay, there's no insulation layer there. So you have a convection happen to the side. The length is 9 meter. Temperature on the left is 200 degrees C. And you're given the H infinity on the side and on the end here. Radius 2 meter. You need to solve the heat transfer problems. What else? The rest is given, and you need to determine the temperature at 3 meter. You need to find the temperature at 3 meter from the side here. So what is a T over there? So what you need, what you need to do, you just need to break this rod into a few sections. So since we need to find temperature at 3 meter, so we just break into 3 sections or 3 elements. So we have first element 1 to 3 meter or 0 to 3 meter. The second one 3 to 6. Then the third one is 6 to 9 and so on. Okay. K value is given, H value is given, free stream temperature is given, meaning at the end here is 20 degrees C, or the site environment temperature is 20 degrees C, and so on. So let's try to solve this question. It's quite direct. So the first steps for chapter 7 question, first steps, break them into element and then label the point. So in this case, because we need to find the temperature at 3 meter, so we just break into 3 sections. So we have 3, 3, 3, and then you label 0.1, 0.2, 0.3, 0.4, label the element 1, element 2, and element 3. Then put in the temperature 200 degrees C, and you can write 20 Celsius above, 20 Celsius at the end here. So just to help yourself when you substitute the value later on. Okay. Any question for the diagram? So we have any question on the diagram?
No.
Okay.
No question.
Okay, good. Then the next one, we call out the K complete equation for heat transfer. You have the Kxx divided by L, 1 minus 1 minus 1, 1, plus the HPL divided by 6, 2, 1, 1, 2, and the N heat transfer by convection. Again, this is a complete equation. The first one will give you conduction. Second one, convection. Convection means this one is there any heat to the side? In this case, confirm yes, because there is no insulation there. So you need to calculate the middle one. And then the end here normally is a side. So the side here, point number 4 is exposed to the end. Okay. Okay. Just a quick test. Brian, let's look at element 1. This question for element 1. If you want to calculate the K matrix for element 1, looking at the equation you see on the screen here, which one you can cancel? The first one, second one, or the third one? Which one you can cancel out when you calculate element 1?
The third.
The third one, huh? Okay, good. All right. Then I ask the next question. Ashmal, what about K matrix for element 2? Which one you can cancel out, or you need to write all? The third one, same as number 1. But again, the ticketing number is different. Okay, Chia, what about number 3?
We have to use all.
Okay, element 3, we have to use all because it's exposed, no insulation layer, and also there's an N convection there. So just be careful on that. And for the numbering of the ticketing number, so again, for the element 1 is 1, 2, 1, 2, and for the element 2 is 2, 3, 2, 3, and element 3 is 3, 4, 3, 4. Okay, then after that you combine them into big matrix. Just be careful on the numbering, because once you label wrongly, you are not able to part them correctly. So the full K matrix we expected will have 4 times 4 matrix. It's a very big matrix. Why 4 times 4? Because you have 4.1, 2, 3, 4, 1, 2, 3, 4. So you part according to what you see over here to this one. Okay, I think all of you understand the concept. So I'll just go ahead and give you the answer. So yeah, basically the next step, we just transfer this one right as this equation. HA0001. So in exam, give me this equation and this equation, yeah? This one 1 mark, this one 1 mark. So if you didn't write this one, well, you only get 1 mark if you write the second one. Okay. Next, you just calculate the constant over here. You calculate what is A, what is KXX, what is L over here. So K is given, A in this one is round body, so pi r square, L is 3 meter. Huh? Again, this is the area where students make mistakes. They will tend to forget that this is element. They will use 9 over here. So take note on this one. Huh? Okay. Then you calculate the HBL divided by 6, this constant value. Substitute, you calculate the perimeter of P. How to calculate perimeter? 2 pi r. L is 3. You get 2 pi. So the first one, 4 pi. Second one, 2 pi. The third one, HA. A is pi r square. So you have 4 pi. So first one, second one, third one, the unknown, not the constant value you have. Then the rest you just combine them or substitute them accordingly to element. So for element 1, because element 1 do not expose the end, you have the convection to the side, so you only have the first component and second component. Oops, sorry. Okay, so for element 1 you have these two, the rest is the substitution. You see the second row, third row. Okay, third row is just a mathematics modification, because when we add two matrices together, just for our convenience, we just change to 4 pi. But anyway, you can just substitute inside there and then you do addition also can. Okay, so the row number 1, 2, 3, 4 is just a mathematics procedure. You can skip this step and give me the final answer like this. Okay, so the first one you have 4 pi, 2 minus 0.5, 0.52. Okay, or you can just substitute inside to get the full metric without the constant value outside there. Okay. Any question for the first element? No? Okay, I continue. So element 2 will be the same. You get the same matrix. However, the ticketing number is different. So you get K1 and K2. However, let's see what happened to element 3. Element 3, you need to include the NHA value because it exposed the N here. It's opening, so you need to add the third component. So the rest is just mathematics. At the end, you arrive at K3 equal to 4 pi, this number, and then the rest is just superimpose. And then this one, this equation is this 4 equation is to find the forces. Okay, find the forces. Again, if the question there's a heating element, then you need to calculate the first one. However, this one you do not have heating element, you don't have to calculate the first one. In here, there's no heat flux mentioned in the question, so you don't need to calculate this one. And however, you have the site in this case. You have a convection to the site. So there's a force. So you need to calculate this one, and you need to calculate the N force over here. Okay. This one also based on element. Based on element. If the element is insulated, then you don't need to calculate the third equation. And it depends whether the element exposed to the N. If exposed to the N, then you need to calculate this equation. Okay. It's just a remind you when you need to use, when you don't need to use. Okay, so for element 1, this one, element 1 is here. Because it do not have any insulation layer, you have a H released to the side, but you don't have the N here. So you only have the middle equation, which is the FHS, FH, that is H released to the side. So you just calculate HT infinity PL211. Again, what is the value? What is the meaning of the first matrix here? It means 0.1. This one, it means 0.2. What does it mean? If you multiply the products into the matrix here, the products will be F1 and F2, means force at 0.1, force at 0.2. Okay, just take note on this one. Okay, the rest substitution, you get 4 pi something. Element 2, also same. Element 2 over here, since it is connected, so this N is connected, so there's no N exposed, and it only relates to the side there because it's not insulated, so you have the H force there. We are now calculating the force, so don't confuse with the previous one. We are now looking at force. Okay, force in this equation, HTPL divided by 211. Substitute again. This value is 0.2. This value is 0.3. Yeah. This value is 0.1. This value is 0.2. Okay. All right. So as you can see here, the force at point number 2 is same. This is if you multiply the products. Okay, if the question just give you a bonus point, ask you what is the force at point 1. What is the answer, Brian? What is the force at point 1 from this matrix? Brian?
Yes, sir.
What is the force at point 1?
Zero, sir.
Okay. Well, tell me what is this number mean to you? What is this matrix position means to you? What is this position means to you?
So that 1.
Position 1, right? So what is the products of the answer here? This one equal to force 0.1 at 1. Equal to what?
30. Oh, minus 10.
Think before you answer. Just a simple mathematics question. Huh?
So is it 376?
Give your answer in pi. What is the product of these?
Pi.
120 pi. Second value?
120 pi.
Okay. What is this matrix tell you? This matrix is what? Force element 1.1. Force element 1.2. So this is the force at this point. This number here is force at point 2. So my answer, my question just now, what is the force at this point?
So 120 pi.
120, wrong answer. Did not give me the
120 pi.
Yes, the correct answer is 120 pi. For 0.1. What is the force at point number 2?
120 pi.
Okay, good. Okay, Sue, I just want to test whether you understand or not. What is the force at point number 2? According to this second equation here.
Okay.
So what is the force at point number? What is this meaning? Okay, you get the products of 120 pi, right?
Yes.
120 pi. Or maybe I ask you what is the force at point number 3 lah. Okay, point number 2 first. What is the value of point number 2?
Point number 2. F element 2 1.
1. No, it's
No,
2.
no. Yes, F element 2 and F element 2 3.
So the value for point number 2 here is 120 pi. Then here is also 120 pi. So it means that this value agree with the previous one. Okay, it's agree. Means that you're doing the correct calculation because this point is connecting element 1 and element 2 and the temperature should be the same. Unless what different? Unless they're using different K value or different H value, sorry. Then you get the wrong, you'll get the different, okay? All right. So I just want to ask question to check whether you understand the value for this matrix or not. All right. You do the same for element 3. However, element 3 have one more equation that you need to consider, which is the n. This one, because it's exposed to the n, you have 2 convection to the side force and also the n here. So we are calculating the force here. So you need to use these 2 equations. So I'll just give you the numbers. So you have the final answer as 40 pi times 30 and 50. So actually the answer, the full answer for this one is 120 pi and 200 pi. So by looking at the answer I gave you, Chia, what is the force at point number 4? I'm asking you point 4 forces. Maybe I look at element 3. What is the force based on these slides. Sorry, Chia, I tried to answer just now. I can't get your voice over.
200 pi.
Correct. Answer is 200 pi, yeah? Answer is 200 pi at point number 4. There's a force there. Okay, so since the whole class understand, so the next one is just, again, use back the F equal to KT, not D, yeah? Temperature. So you combine the K together. So I don't think I need to repeat how to park the number. So you get F equal to KT. As you see on the screen here, the blank one is 0. I didn't write out. Okay, I just show you the operation. Okay, F equal to K. This whole thing is K. But you can substitute this one inside there, no problem. So you'll get this equation. And you have 4 equations to solve. All right. So again, we need to repeat the same strategy to change the first matrix, first row number by using information on the screen here. So we need to change the first number on the left and the first row by matching the condition of T1 equal 200. Okay, so the new matrix here, after you rearrange, you'll get 4 pi bracket T1, T2, T3, T4. Apologize for my writing on the screen. Okay. What is the first number that you should write on the top here? Chia? What number that you can write by using T1 equal 200?
So you mean which
Oh.
top?
Yeah, here, this one, this location. What number that you should put here? And then what number you should put here? What number should you put here? What number you should put here? What number you should put here? To get this T equal to 200. T1 equal to 200. So what should you put over left hand side here?
The left and
200. So this one, 1. This one 0. This one 0. This one 0. Okay. So of course this is not 1 because you have to apologize. This is not 1. Apologize. It's not 1 because there's a 4 pi there. Okay, there's a 4 pi there. So I'll just give you the direct answer. So you rewrite the equation. Okay, in this case, you have the force already. So you just rewrite the equation, fill in accordingly as I show you here. So force number 1, F1 equal to 4 pi 30, 30 means you can write F1 plus 4 pi 30 because this is point number 1, this is point number 2, point number 3, point number 4. Okay, you transfer the information here into this matrix. Okay, this is point 1, point 2, point 3, point 4. So here we have point 1, 0.2, 0.2, 0.3, 0.3, 0.4. So that's why you see there's a 2 number plus there, because you have 2 point, 2 point number 3, 2 point number 2. Okay. So once you get this equation, you combine, you rearrange the equation. Okay, you rearrange the equation means we take out the 4 pi inside the equation. So the first one, you get F1 4 pi plus 30, 30 plus 30, 30 plus 30, and 50. So I remove the 4 pi from the equation. So basically I have a new matrix here. And then I do some calculation. Okay, so basically you have 3 equations over here that able to help you to solve. Okay, how do you solve? Are you able to see the first equation? 60 equal minus 0.5, this one, times T1 plus 4 T2 plus minus 0.5 T3 plus 0 T4. You get the first equation. However, T1 you have the value already. T1 is 200, so you substitute in first equation. So basically, you having 3 equations. Repeat the same for the second one. 60 equal 0 times T1. Apologize for my writing. Plus minus 0.5 T2 plus minus, sorry, I'm doing the correct one. Yeah, correct. The third one is 4 T3 plus minus 0.5 T4. You repeat one more time for the third equation, because T1 value you know. So 50 equal blah blah blah. Get 3 equation, 3 unknown. You're able to solve T2, T3, T4. Brian, you get the idea?
Yes, sir.
Ashma, you okay?
Yes, sir.
Right, good. So I already tell you how to solve the equation over here. Remember, when you solve, remember there's a T1 value there. All this, yeah, there's a T1, there's a T1. So normally the mistake student will forget this one. Okay, so from here you get T2, T3, T4. So the question asks you what is the temperature at this point,